Dr. K. Wang from Chongqing University of China. So Dr. K. Wang is an associate professor at Chongqing University, and his research interests include intelligent vehicle, environment perception, and AI. And Dr. Wang will be talking about the adaptability and challenges of autonomous vehicles to pedestrians in urban China. So over to you, Dr. Wang. I'm putting you in the spotlight so that you can share your screen and start your presentation.
Okay, so I will show my screen first. Okay.
That's good. Could you please share your slide?
Yes. Yeah. Hello. Can you hear me all and see my screen?
Yes, that's all good. Go ahead, please.
Okay. Hi, guys. This is K. Wang from Chongqing University. And firstly, many thanks for Professor Huang and Professor Li's invitation. It is my honor to be here. And today, I will show you a topic named the adaptability and challenges of autonomous vehicle to pedestrian in urban China. Okay, let's begin. So the next picture is the framework of our efforts, and this is how we organize the order of this show. All in all, there are 4 parts. Firstly, we will talk about why we decided to conduct this research, and then we will share a message that we review and conduct our analysis. Following it, we analyze the 3 typical phenomena of Chinese pedestrian and a comprehensive literature review of driverless technologies for pedestrian and adaptability analysis provided. Then adaptability, emerging challenges and opportunities for future pedestrian research were proposed in the last. Okay, so why we do research? The idea of research comes from the situation of Chinese pedestrian. So Chinese pedestrians are vulnerable. 26.1 traffic deaths is related to pedestrian compared to 16.1% in America. Meanwhile, China has the most pedestrians violate traffic rules seriously. A study shows 18% of pedestrians were wrong red lines. So the left picture shows a scene of Chinese street, and recently, AVS developed fast. Big companies such as Google, Baidu, and BMW take great effort to conduct research in this area and get a lot of achievement. The next picture shows the SA China roadmap of AVS. However, there is a gap. Little is known about the adaptability of AVS to Chinese pedestrian. And the technology for AVS is local sensitive. Thus, we are dedicated to research. We conducted pedestrian phenomena analysis about AVS, and we summarize the AV technology to protect and interact with pedestrian. And last, we concluded the adaptability and opportunities. Okay, so to analyze the adaptability step by step, we divide it into 2 main questions. The first question is, what are the Chinese pedestrians' characteristics and their technical demand for AVS? And the second is, what are the current ability of AVS when facing pedestrian? By solving the first, we know that the safety demand for Chinese pedestrian, which will be worked as our criteria to evaluate adaptability. Then, through reviewing articles, the current abilities of AVS will be summarized. By combining the 2 answers, the adaptability will be analyzed and developed. The answer to adaptability of AVS to China in urban pedestrian, we can get the answers. So the pedestrians are vulnerable road users around the world and recognized as the worst victims because they are directly exposed to the impact of traffic crashes. Compared to the vehicle passengers or other road users, the pedestrian is very victim. In developing countries, pedestrians will be safer. According to the road trauma in Australia, in 2018, the death to injury rate of Australian pedestrian is 4%, and in America, the rate rise to 8% according to the road traffic statistics. However, as the biggest developing countries in China, China has more severe pedestrian safety program. According to the statistics of government of China, the death to accident ratio of pedestrians is about 15%, which is far worse than that of car passengers, as well as cyclists, as table shows. So there are some phenomena in China. Wrong red lights are common sense in China's street. A study shows that 60% of pedestrians will agree to run the red lights. This behavior is easily by the conformity phenomena and often happen in group, which cause pedestrian occlusion. The occlusion will cause a misunderstanding of pedestrian intent and wrong direction of pedestrians for the autonomous vehicle, and possibly causing accidents. And a study showed that 68% of pedestrians were jaywalking in China. In this saying, the car must detect pedestrian from long distance because cars are so fast and the drivers need more time and a long distance to stop. Pedestrians are irregular and cars are fast, which is unsafe, And pedestrians are small in same data for the autonomous vehicle, and cars are often fast. In this sense, AVS must detect the small pedestrians and need method to interact with pedestrians. A study showed that 5.4% involved in an accident because of phone use, like the following pictures show. What's more, Lin emphasized that the time to cross a road would increase, and the time pedestrians walk around would decrease when they use phones, and they would be more likely to conflict with pedestrians. Moreover, the phone utilization would cause distraction, which would hinder the intent communication between the pedestrian and the vehicles. As a result, drivers don't know how to respond to the behavior accordingly and cause accident. So based on above phenomena in Chinese street, the pedestrian safety requires good detection for the autonomous vehicles, including small pedestrians, occluded pedestrians, normal pedestrian detection, and distracted pedestrian detection, and communication between cars and the pedestrians. What's more, there is a hidden factor, receptivity, that plays an important role in the relationship between AVS and the pedestrian. If pedestrian can't accept AVS, then the communication is meaningless for pedestrian. Correspondingly, the technical demand of pedestrian for AVS will be summarized in the following to compare the demand and technical status. So in the slides, you can see some technical demands and the technical status for autonomous vehicle is shown in the slides. Okay, so left picture show the normal pedestrian detection related to 5 data stage. We set the occlusion level of pedestrian to normal values to reach the normal pedestrians. It shows that the best results are 6% miss rate in cottage and 7% in ETF. The environment we talked in the research in China urban environment is more likely in cottage. So in this way, the pest detection in the current technologies is excellent, we think. And the detectors for the AI technology is in easy occlusion of kitey has an excellent performance, since 88% of the pedestrians are detected. However, the performance become particularly poor, especially in heavy occlusion in cottage and in hard in kitey. For 49% of pedestrians are missed. More importantly, the change rate is huge when the difficulty of sceneries changed from easy to hard. Yeah. Considering the importance of the easy occlusion and heavy occlusion, we think the detection for occluded pedestrian is bad in the current state. Okay, and detectors in medium scale has the best performance with the lowest miss rate of nearly 0%. However, when it comes to medium scale, the performance drops dramatically with the lowest miss rate of 23%. Yeah, to make the matters worse, detector in the fast scale has a terrible miss rate of only 16%. The medium scale pedestrian data is more suitable for Chinese urban pedestrians. Therefore, the best performance is of the algorithm with a miss rate of 23%. Then we can draw conclusion that dryness technology is okay to detect the small pedestrians, but has some rooms to improve the algorithms. And the distraction usually happens when pedestrians are reading books, talking to others, as well as using phones. Is the main reason. However, there is little research to further the study, and the code is not available. So the real effort is doubtful. Yet, surprisingly, phone utilization hasn't always been terrible for AVS. It could be an interaction way. For example, you can use the vehicle to pedestrian, or we call the V2P communication technologies, or V2V technologies, as a method to guarantee the active safety. So in which smartphone works as a receiving device. So in all, in the area of detection form use, the adaptability is okay. And when it comes to the interaction between AVS and two pedestrian is to transfer intent to the pedestrian. Well, in the current researches, they use LED strips, LED displays, road driver, speaker, wide-share mirror to show what's the AVS mode, what AVS could do, and what AVS help pedestrians do. And the warnings, however, there are some shortages. Yes, single feature has the shortages. To tackle the shortages, a fusion or multiply features is a promising method. So some companies such as the Google or BMW also use this method. Yeah. Furthermore, interaction needs a standard language to decide what interface to use or how to use the method to transfer more informations and reach higher robustness. In conclusion, equipped with external features, AVS could transfer the following status. So the vehicle about to start, about to stop, and slowing down, and starting AV mode, as well as observing the pedestrian, and there are some challenges. So therefore, the adaptability we think is okay in the current state. Then the receptivity. So in some studies, the geomagnetic reflects some basic properties of persons, and is thought to influence the receptivity. We found males and young people tend to trace AVS due to more interest in new technologies. And understanding to AVS has a strong relationship with receptivity. We found an insufficient understanding of AV would need to mistrust and made up explanation for the behavior of AVS. And third, the interaction between AVS and the pedestrian also promotes the receptivity. Yeah, some researchers discovered that after interaction with AVS once, the pedestrian could gain a close understanding to AVS, hence promoting trust and acceptance. So we also discovered the pedestrian trust in the AVS of Uber, because the Uber has the largest engineering quantity, while others doubt Uber for its fast speed to develop AVS. Accidents related to the AVS harm the receptivity, because negative events are more visible compared to the positive events. So the small events, even totally no responsibility from AVS, could set off a number of resistance. So next years in China, there are many robotaxi drive on the road. So some cars from Baidu and some cars from other companies. Such things give more real experience to consumers. Therefore, we think the receptivity is okay. So in conclusion, we summarize the adaptability of AVS to the pedestrian to open China. The interaction features could transfer the state of AVS to pedestrian, but need a standard language to manage external interface. And the driverless technologies could detect a normal pedestrian well. Moreover, in small and distracted pedestrian detection, the perception is okay, and there is a room to promote. And the worst thing are pedestrian with heavy occlusion, and the detectors has very bad performance in this situation. Additionally, the influence factors of receptivity reflects the importance of real experience with AVS. Nowadays, in many cities, such as in Beijing, in Shanghai, in Guangzhou, there are many companies, such as Baidu, Apollo, Robotaxi, and other companies. So these companies invited citizens to take AVS and give them the real interaction with AVS. And therefore, we think the receptivity is okay in the current state. So as talked about, there are some features. So research areas, including the challenges, opportunities, first the standard interaction languages, and the interface fusion of HMI design, information's overload avoidance on HMI design, and small pedestrian detection, and heavily occluded pedestrian detection. and more distracted pedestrian research. So this is my presentation. Thank you.
Thank you, Dr. K. Wang, for the nice presentation. While we wait for the questions, by the time you have presented, somebody has posted a question for you or a comment.
Okay.
His comment is that the Chinese pedestrians now abide by the traffic rules and do not have so many bad behaviors.
Yes.
The pictures would not be suitable in some extent. So this is a comment. So we want to reflect on this comment.
Yes, you know, China is the world's largest automotive market, and it's ambitious for the autonomous vehicle, I think. So as one of the key goal of AVS for many companies, so I think the pedestrian safety is the important in use in China. But however, you know, just as you said, there is a gap in the current state. So there is a lack of researches on the adaptability of AVS to pedestrian. So we do some reviews from both the phenomena in the Chinese street and from the current technologies, the state-of-the-art technologies. So, and we draw some conclusion. So, you know, as I have shared that.
Okay.
Yeah.
Thank you, Dr. Wang. I had a follow-up question. Like, for example, you have talked about the change in the automated vehicles interactions or mechanism based on the detection of the pedestrians and their types, right? And now, in order to make this whole automated vehicle system, you know, viable for the real world, we have to make sure that the detection happens 100% with 100% accuracy, right? So, but if we lose one pedestrian to detect by the automated vehicle, there is a high risk of collision, right? So my question is that based on the research that you have done, I'm just trying to picturize what would be the future research direction or future adaptability of these kind of technologies. That do you think that automated vehicle industries should be thinking of making a foolproof of method of detecting the pedestrian, and what will be your thought that if pedestrians start to challenge the automated vehicles, like say they know that automated vehicle will stop, so they would not scared and but just step into the road, you know? So there are some dilemma around that one. So what would be your thought around this interaction between the pedestrians and automated vehicles in the future?
Okay, so just as I said, I think that for the pedestrian detection, because the pedestrian is some you know the small than the cars or the other road users. So to detect the pedestrian is a very challenging technologies for AVS, and the pedestrians may have so many features or so many gestures, and in the current state, the technologies I think don't have the enough abilities to detect the pedestrian, because so many technologies use the AI-based technologies, but the AI the technology has the shortages, because he can't guarantee which rate the detection rate is okay for the current state.
Okay, thank you, Dr. Wang. Thank you for your time and the nice presentation. And this is very interesting research.
Okay, so thanks.
Please continue your research, and we will be seeing more papers coming from your group. That's good. So we'll be now moving to the next presentation. So Dr. Wang, could you please stop sharing and remove your
OK，好，
turn off the camera.